Hello. Okay, let's talk related arrays. So what I'm going to cover in this video is just on the last page of the handout here. The last page of this week's of the week 1 and 2 handout is on related arrays, also sometimes referred to as parallel arrays. This is something that we are going to be dealing with all the time in this course. Our machine learning data is going to come to us as a set of related arrays. One array will hold the data and the other array will hold what are called the labels or the class labels for the data. So it's worth taking a look at the tools that that we're given in numpy to deal with related arrays, because it's really quite cool, and it continues. Again, it's super expressive. You can write tons of complicated stuff with just a couple of lines, or you can do tons of complicated things with just a line or two of code. So first of all, what is a related array or a parallel array? I'm just going to call them related arrays. So let's say you have, let me import numpy as np. Let's say we have, I'll use an example similar to the one in the handout. Let's do np.random.randint. So we've got scores. Let's say they go between 100 and 200, and there are 5 of them. So scores will be a one-dimensional numpy array with those scores in it. And then we'll go names equals np.array, and we'll make this array out of 5 names: Sam, Anne, Max, Rosa, and Lou. Okay, I'm keeping them lowercase just to keep things simple. And then there's, let's say we have the ages. So this is some kind of a game application we've got here. How old is Max? 7. Rosa's 5. And Lou is, I'm not sure. I'm going to say 34. Okay. So what we've got here is some kind of a game, or maybe a web application. People are playing against each other. Every player has a name, every player has an age, and every player has a score, most recent score. In an object-oriented system, you might create an object for a player, and that object would contain all this information. It would have a field for name, it would have a field for their current score, and it would have a field for their age and any other information you would want to track about a player. And then you might keep the players, those player objects, in a single list or a single array. In array programming, you split that information across multiple arrays. So we don't deal with objects, generally speaking, in array programming. We don't have arrays of objects. We have arrays of basic data bits. So you can think of this, if you look at these 3 arrays: scores, names, and ages. The first player object has a name of Sam. It's in index 0, an age of 50, and a score of 169. The second player object has a name of Anne, an age of 42, and a score of 161, and so on. So the information is stored almost like you would store it in a spreadsheet, where each row might contain the information for a particular attribute, and each column then, in this case, is representing essentially an object. So these are called related arrays because, so if we take a look at names 2, that's Max. If we want to know Max's score, we use the same index to go into the scores array. We find out that he has a score of 198, and we look at the ages at the same location to see that he has an age of 7. Okay, now representing the data this way has a lot of advantages. It's quicker and easier to access a lot of stuff. It's a more compact representation. With object-oriented programming, there's a lot of overhead where you're calling getters and setters, and every time you do that, you're using a lot of resources to make those method calls. Here we access the data faster, so we get a little bit of speed for representing things this way, but we lose some convenience. We can't just go to a single object and ask for its age. We have to do something different for it. Now, if you want to know, now I've already shown you some tools that are going to work for this. So if we go names names equals Sam, for example. Oops, sorry, double equals Sam. We will get back an array of all the places where this is true. Okay, so names equals Sam, like that, gives us an array of true and false values. Any Boolean on an array does that, and then you can pass that as an index to find out the value there. So when you have related arrays, if we want to know the score that goes with the name Sam, we can do this, names equals Sam, like that, and that'll get us that score. If we want to know the scores, if we want to know the names of all players who got a score of higher than, let's say, 150. Let me look at the scores here. Yeah, 150. Names, so we want the names where the scores are greater than 150, and there they are. Okay? Maybe we want the average age of the players who scored greater than 150. Well, we can get the ages like this. So the ages where the scores are greater than 150, and then we just go dot mean to call the mean method, and we can see that the mean age of players who scored over 150 was 33. Okay, so it's the same tricks I showed you before here. This isn't anything new. It's just that when we have related arrays, we can index one array using a Boolean expression on the other related array to pull out stuff pull out the information that we want. Okay, so if we take a look at the example here, it's a simpler example. We just have names and scores, and here's some examples of finding things. This will get you all the names of players who scored higher than 100 or more, and this will get you a single array with the score just of players named Max. But it goes beyond that. So I want to introduce the arg methods to you. So let's say you want the highest score, right? You want the highest score player, or maybe the oldest player. So let's take a look at scores.max gets you the largest number in that array, but it doesn't tell you where it is. So let's say you want the name of the player who won the game, right? By picking out their highest score. Scores.max isn't going to do it for you. It tells you the highest score, but then there's still work to do to figure out what name goes with that score. So because of that, to support related arrays, there are these arg procedures. So scores argmax returns the index of the highest score, which is exactly what you want. So if you want to know the name of the player with the highest score, it's names scores.argmax, like that. So max won this particular round or whatever, because that's the name that goes with the highest score. Okay, you can also, there's also an argmin. So let's say we want the score of the youngest player. It would be scores, ages, argmin, like that. Okay, and notice that these argmax and argmin, these are methods that we're calling. So this will get me the index of the smallest age, the lowest age, and then it will pull out the one item from scores that equals that. Okay, so if we check that, the youngest player is 5, and her score was 118. Okay, so that's argmax and argmin. The other thing that you might often want to do, you've got names, ages, and scores, 3 related arrays. You might want to sort them. Like you might want to sort in order of score or in order of age, or you might want to alphabetically sort them. We can do that for a single array. If I go names.sort, like that, it sorts my array, my names array, but now it's messed up the association. It's messed up the relation between this array and the other arrays. So I can't just sort this array. Let me see if I can restore that to what it was supposed to be. I'm just using the up arrow here to go back through old commands, get the names array back the way that it was. So now we've got names, ages, and scores. And what I want to do is I want to sort this stuff in alphabetical order, but preserve the ordering down here. So there is a method for that. Names.arg_sort. Arg just means, I guess, argument. So the position, the index. This tells me what it's telling me here is that if you want to sort names in ascending order, take name 1, which is Anne, then name 4, which is Lou, then 2, which is Max, then 3, which is Rosa, then 0, which is Sam. So it gives me the indices, the indexes, that would the order of the indexes that would be required to sort this array. So I could do something like this if I want to do it kind of efficiently. I can create I, which is an array of indexes that I want to sort everything in. And remember, if I go names and then give it a list of like 3, 2 like that, it pulls out, it creates a new array for me with just the name at index 3 and the name at index 2. So now that I've got this array, I can pass it into the names array. Names I is going to be the sorted version of the names. Now that doesn't change names. Names is still the way that it was. When I do this, it creates a new array for me. So what I want to do now is to sort the arrays and preserve the relations. And let's just take one last look at the way things are supposed to be so that we can check our results. Then we go names equal names I, using the arg sorted indexes. Ages equals ages I, and scores equals scores I. So I've taken, what I did was I got using argsort. So I equals names.argsort. So it represents the ascending order sort of the names array. It's the indexes for it, and then I can use that index here, here, and here, that set of indices, to rearrange all 3 of my parallel arrays, all 3 of my related arrays. So if we look at the original arrays here, for example, let's pick a name. Where are we? Rosa is 5 and had a score of 118. So let's take a look at the way things have landed. Oh, Rosa hasn't moved actually. That's not a good one. Let's take Sam. So Sam is 50 and has a score of 169. Sam is now at the end of the array. He is still 50, and he still has a score of 169. Okay, so and I've now sorted all 3 of these things using the argsort to get me the indexes, and then I pass those in to sort each of those 3 arrays. So that's pretty cool. What if I wanted to sort in descending order of scores? Maybe I want to get the top 2 or the top 3 players. Well, I could do it like this. If I do scores.arg sort like that, I get an array that represents the ascending order sort. So 3 is this item here. It's the smallest item, and 2 is the largest item, which is this one here. I want it to go the other way around. The simplest way to do that, scores.argsort gives me an array, and then what I can do is I can use, I think I showed you this before, the slice operator. So for example, in the slice operator, if I go 2, 4, it's going to give me just that slice from item 2 up to but not including item 4. If I go :4, it gives me everything from the beginning up to but not including item 4. If I go 2: it gives me everything from item 2 up to the end. And if I go just like that, it gives me everything from the beginning to the end. So it creates a new array like that. Now I'm also allowed to put a step value on here, so I put another colon. So I'm saying give me the whole array, and then this other one is going to specify a step value, and I'm going to specify -1, which is going to turn the array around. So this array is the ascending order sort, this array is the descending order sort. So I do get that back with an up arrow, I equals scores.argsort reversed. Now I've got an index array for a reverse sort by scores, and then I just do what I did before. Names equals names I, ages equals ages I, scores equals scores I, like that. Now I've got, the names are like this. Sam is now in the second position, is still 50, and still has a score of 169, but now all 3 arrays have been rearranged in descending order. So now if I want the name of the first 2 players, say the top 2 players, now that they're in that order, I can go like this. So that says go from the beginning up to but not including index 2, and that gets me the names of the top 2 players. Okay, pretty cool stuff. I think it's cool anyway. I hope you guys do. So here's a bunch of examples. There you go. It's the same example that I showed. Sorting names by score. Here I didn't use an intermediate variable I just put scores.arg sort directly into names. And since I didn't have, since I only had 2 arrays, it was easy to do, I guess. But if you're going to use scores.arg sort a bunch of times, best to probably, I mean, from an efficiency point of view, to store that in a variable and then reuse the variable rather than making it do the sort over and over and over again. There is also a where method. There are some methods that are just hanging directly off of the NP module. They're not methods of objects. They're more like global functions within the module. The one that students often find is this one. It doesn't always give you something that you couldn't do another way, but it can be handy. So if I say, where are we? Go back to my Paizo here. If I say scores greater than 150, I get this. But sometimes what I want is a list of indices. So instead of just true, 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 essentially this is giving me a related Boolean array that's related to scores that tells me where the scores are greater than 150. But sometimes what I want is the numbers. So NP where basically just goes through a Boolean array and gives me the indexes of where that array is true. Like if I do this, true, false, like that, it just says 0, 2. So NP where just tells me where the Boolean array is true. So that can be handy to convert this result to a list of indices. In the end, though, it doesn't make a whole lot of difference. If you want the names where the scores are greater than 150, it doesn't make a whole lot of difference for what I'm doing here. There are some places where it could be quite useful to do this, so keep it in mind. But right here, this has the exact same effect as saying np.where scores are 150, like that. You get the same result. This is doing it with one less method call, so it's a good idea to do it this way. This gives you a Boolean array which is used to index into names, and this gives you a numeric array that looks something like this that's used to index into names, but the end result is the same. Okay, last thing, this is something that you will want, this is something I'm highlighting here because it's something that you will want to do. So let's say we want to shuffle the order of the players. Maybe a new game is starting and we want to shuffle them. So let's take a look at the state of things. Right now we've got names, ages, scores. So we are sorted by the score in the last game. But now what I want to do is I want to just do a shuffle sort. I want to just randomize the order so that the players can go in that order. But again, I don't want to lose the information that's related between the arrays. So I can use arange for this. So arange is like the range operator. It gives me, it actually gives me a complicated object, an iterator. Oh no, it doesn't give me an iterator. Sorry, it gives me just gives me an array. So give me an array ranging from 0, because I didn't specify a start, up to but not including 5. That's what I want. You can also use the length method if it's just a one-dimensional array. You can say give me a range up to the length of one of the arrays. So let's do that. I equals np.arange len names, like that. So there's my index array. Now I want to shuffle it. np.random.shuffle I, and now I is shuffled. The 0 is still the same, but the others are different. So I can shuffle this index array. So what I did was I created an index array from 0 to 4, and then I can shuffle them. Shuffle. Now what does it look like? Now it looks like, whoa, look at that. What are the odds of that? It shuffled it back into its regular order. There we go. There's a bit more of a shuffle. Wow, that blew my mind. Okay. So that's randomness, though, right? All arrangements are equally likely. So I guess it's 1 in 120, I guess, chance that it would sort it back to the original order. Okay, so I've got my index array now, I, and I can basically I just do the exact same thing I did before. Names equals names I, ages equals ages I, scores equals scores I. And if I take a look at them, names, ages, scores, I now have a new random arrangement. Sam is still 50 and still had a score in the last game of 169. Okay, so a whole bunch of tools to do things really easily with related or parallel arrays. Stuff that would require loops in other languages, loops and sort of more, just more code, more lines of code. You can often do in one line what would take 5 or 10 lines in another language. So it's pretty cool, and it takes a little bit of getting used to. The first assignment, which is going to be introduced in the next video, one of the things I'm going to be looking for there is limited use of loops, because that's usually a telltale sign that somebody hasn't really internalized what numpy and array programming can do for them, is if they start looping over an array. There will be some places where you have to do that, or where it's easiest to do that, like when you're outputting things. If you're outputting a report of the 5 players and their ages and their scores, there may be a way to do it, a compact way to do it, but it's probably just easier to just do a for loop to display that stuff. But anytime you're doing any kind of processing, reordering things, finding the best player, finding maximum and minimum items and so on, all of that stuff should be done without you writing any loops. Of course, there are loops there, but they are deep inside the NumPy system and implemented in a really efficient way and compiled to be fast. Okay, there are some exercises. Oops, let me just go find them here. Basically, there's 3 exercises for, here we are. 3 exercises for this section. They're at the end here. NumPy related arrays. I just want to give them a try. Okay, so we're going to make 20 random coordinates, XY coordinates, and you'll have one array for the X's and one array for the Y's. So you'll have a pair of related arrays. And then I want you to do some stuff here. You should try these out. The solutions for all these are online, of course, but you should try them yourself. These are going to help you when we get, in 2 weeks, when we get into our first machine learning algorithm. We're going to be doing stuff a lot like this, computing distances between locations on a 2-dimensional grid, or actually on a multi-dimensional grid. So getting this done and accomplishing it yourself is going to set you up for success there. I should also point out that there's I found this GitHub repository. I actually haven't checked it to see if it's still good. Yes, it is. So here you go, 100 NumPy exercises. So I found it's just 100 really simple things to do, and I sort of curated a few of them that I thought were useful. But I've preserved the original numbering. So if you want to go try those, it's a great exercise to learn more about NumPy. As you go through, you can Google things that you're not sure about and get information that way. And yeah, so you can try some of those as well if you want some more practice with NumPy. Okay, so that's it for now. I'll see you guys in class, but there is one more video where I'm going to introduce the assignment. So I'd like you to take a quick look at that before you come to class as well. See you in the next video.